Hello guys, welcome to new video. So in this video, we are doing this question, intergalactic ozone. So first of all, we read the description, then we see the approach of this question. After that, we're doing the code for this question. You are recently purchased a new game, which is about a war between humans and aliens. In this, you set out to destroy all the planets. Since this is a game, the number of planets, their orbiting position, etc. are different. There are n number of planets and m total orbits. M may be less than n, meaning that there might be multiple planets in one orbit. Now you have two machines to destroy these planets. So these are the two important lines in this question. So you can see here machine 1 and machine 2. Machine 1 destroy any planet and uses 1 unit energy. Okay. So it takes the 1 unit energy. This is machine 1. And machine B destroy all planet in an orbit but uses C unit of energy. So it can destroy all the planets that have the same orbit, but it take the C unit of energy. It take the C unit of the energy. Okay. And it take the 1 unit. Okay. So this is the main thing. So guys, you can see here, there are total four test cases here. Okay. Four test cases. This is first one, then second, then third one, and then fourth one. So first of all, we see this thing. So this is the number of the planets that are present, like 2 1 4 5 2 4 5 5 1 2. So there are 10 planets is present. And what is the meaning of orbit? So in orbit number 2, there are two. One is this, and this one, and this one. These are like planet of the two orbit. Like in two orbit, there are three planets, and in one orbit, there are one and two. And you can see here, the four is two here. So in the four, like orbit, there are two planet, and in five, you can see here there are three planets present. So guys, what is the thing here? So here is the second machine uses energy is given here. So the second machine energy is given 1 unit here. Okay. The C energy is given here. The C for this test case is 1 here. Okay. And the first machine is take the 1 unit. So in this first test case, you can like compare both machine that are take 1 unit of energy, machine A, and the second that can destroy the all orbit planets that are take the same energy. Like if there are three planets that has the same uh, three one orbit that has three planet like 2 2 2. So if we use the machine number 1, so it take the 3 unit of the energy. Like first of all, when it destroyed this one, then it take 1 unit of energy. After that, this one 1 unit. After that, this one for destroying for this one is taking 1 unit of energy. Like if we use the machine A, then it take total 3 unit of energy in the first machine case. But our necessary condition in this question is we like you can see here, you can any of these machine any number of times. What is the minimum energy you can use is to destroy the all planets? So we want to destroy the all planets and minimum energy we required. Okay, so when we use the machine A, then it take the 3 unit of energy because it can destroy one by one. Okay. But guys, at the same time, you know very well, the machine number 2 is also taken 1 unit of energy. And in this two orbit, there are three planets present. If we use the second machine, so it take the 1 unit of energy and it can destroy the all orbit element in it act one time and it can destroy the three element one time and it take the 1 unit of energy. So which is beneficial here? So you know very well, machine B is here beneficial, like it take the 1 unit of energy and it can destroy the same orbit all elements. Like orbit number two's three element it can destroy in one time. If take an example, like if there are is one here, Like machine 1 is also take 1 unit and the machine B is also take 1 unit. If here is 4 here, like if take example here at the place of 1 there are 4 present here. Like machine B take 4 unit of energy. So at that time, which one is beneficial for us? If we use the machine number 1, then it take the like 1 unit, 1 unit, and 1 unit. It take the 3 unit. But when we use the machine number B here, so it can destroy the all two orbit element in one way. Like it take the 4 unit of energy and it can destroy the all things at the same time. So when we use the machine number 2, then it take the 4 unit of energy. But when we use the machine number A, then it take the 1 unit for the each element. So this is the less thing now. So that is the main question, like which machine we are using, that is depend upon the energy uses. Okay, guys. So I clear the old diagrams here. So now take the example. Why the answer is 4 here? So answer is 4 here because in this you can see here the machine 1 and machine 2 is take the unit of 1 energy. So which is beneficial? We use the machine number B because when we use the machine number A, then it take the time like 1 1 1. It take the 10 units of time. Like it can destroy a planet one by one. But at the same time, when we use the second machine, so it also take the 1 unit of energy. And when it come in this, like first of all, for first war, it destroy the 2, 2, and 2. 1 unit, then for 1, 2 unit, then for the 4, 3 unit, and then it can destroy the all fives in the fourth round. 4. So we use the machine number B in first test case and the answer is 4 here. 4 is the minimum energy required here. So in the second test case, the machine 1 energy is given here 1 unit, but the machine 2 energy consumption is 2 here. So now take the example of this. So in this, you know very well, the second machine energy consumption is 2 unit and the machine 1 energy consumption is 1 unit. So guys, we compare like if there are one element is present in one orbit, then which is beneficial? If we use the this if we use for this three, like in the three orbit, there are only one planet that are present in this is three. So if we use this first machine, then it take the 1 unit of energy, and if we use this one, then it take the 2 unit of energy for destroying this. So which is beneficial? So we use this thing. Okay, 1. So 3 is destroyed. After that, we know very well when we destroyed the 2, then if we use the first machine, then it take the 3 units of time. 1, 1, 2, and 3. So it take the 3 units of energy. Okay. But at the same time, we know very well the machine number 2 is taking the only energy 2 units and it can destroy the old 2 in one way. So which one is beneficial? We use this machine. So it takes the 2 unit of energy. So we take this one. Okay. After that, for the one, the same thing. If we use the machine number 2, it take the 2 energy for the removing this. But if we use the first machine, then it take only 1 unit. So we take the first one. So 2, 3, and 4. So that's why answer is 4. So I think the approach is like enough that I explained to you. Now we write the code for this question for the better understanding. So I open any ID. So in this, guys, this is our like Java main class, and here I write the test cases. There are 4 test cases that are same in that are given in the questions, and now we write the code for this question. Okay, and after the written the code, I explain all things like what is happening in this question. Like first of all, we are taking the scanner class object. Scanner sc is equal to new scanner and system dot in. So scanner class object is created. After that, we are taking the test cases. So you know very well, I open this thing. So you can see here. There after that, there are test cases. There are 4 test cases. In TC is equal to sc dot next int. So test cases is taken in TC, and we are running a while loop for the test cases till test cases greater than 0. Till now this while loop is working, and now we are storing the value of n. N is the number of the elements in this array. So n is equal to sc dot next int. After that, we are taking the energy that are consuming by the second machine number of b. Okay, so we are storing the energy. So I am taking the k variable here for the storing the value. Sc dot same thing next int. So energy is also store in the k. Now we are creating a map for storing the value. Like we are taking the all things like 2 is how many time is present in this array, or like the 1 is how many times we present. So we can store the key value pair, like the key is any integer type and the value is also integer type, like how many time a integer is occur in this array. So that's why I'm taking here map. So map of the type of integer and integer. Okay, guys. So the map name is map here, and we are also sorting this thing. So how we can sort? So we can use tree map here. So tree map has a property that can sort our map with reference to these keys. Okay. So that's why I am using here tree map. So after the creation of the map, all the keys are come in this map in the sorting order, like 1, 2, 3, 4, 5. So map is created. Now we are creating a for loop. Int I is equal to 0, I is less than n, and I increment. Okay. So now, so I remove this extra space. So for loop is created. Now we are storing the value of the element here. So element is equal to sc dot next int. So what is the element here? Element is here is this thing 2, then 1, then 4, then 5, then 2, these things. Okay. So we are storing the value in element. Okay, guys. So now we are checking if our map dot contains key. Contain contains contains key. Map dot contains key, and if our map is containing the key already, so what we are doing here, we are simply increase the value of that key. So how we can increase? Map dot put, and in map dot put, what we are putting, the key is element that are present, and after that we get the value here. So how we can get the value? Map dot get, and which element we want to get? This element. Okay. And after that this operation we get the value, and then we simply increase the value by 1 because we find out one more element, the same. Else condition, in the else condition, when execute this else condition is executed when our map is not containing this element, the key is new for our map. So at that time we are simply put in our map dot put, and in map dot put we can write here element, and what is the value of element here? The value is 1 here. Okay. So that is the like creation of the map. We are storing the all this array in the map with the form of key and value. Now we are count our minimum energy. So we are creating a variable count is equal to, initially we store the value 0, like energy required is 0 here. Okay. So I turn down this. So count is 0. Now we are running a loop on our iteration in map. So how we can run a loop? So map, in the map we have entry, map dot entry, map dot entry, and the what is the type of entry here? Integer type key and integer type value. So map is type of integer, and we can write here entry, and in which element we want to perform the operation. We want to perform the operation on our map, and how we can get map dot entry set. Okay. So in this way we can iterate in our map. Okay, guys. Now we are storing the value here in key or value. like int key, how we can get the value of key. So there are no need of the key here. So I write here key for the like demo purpose only. So how we can get the value of key? Entry, each entry contain the key and value. So entry dot get key. So in this way we can find out the key, and in this way we can find out the value. Get value. So we find out for the each pair key and value in this. Okay, there are no need to any key here, but for like knowledge purpose, I write this thing. Okay, so after that we are checking if our value is less than k. What is the meaning of this? Like guys, here you can see here the value of key is 2 here, and the value of 2 here is 1 2 second 2 and 3 2. There are 3 2% here. Okay, so key number 2 value is 3 here. So if value is less than k, so we are comparing for the energy. If our energy is less than this thing, so at that time what we can write here, we can add in count plus is equal to our value. So why I am writing here value? So I explain this thing. Wait a second, guys. Else, else what we can write here? Count plus is equal to, and we can write here k. And after that, this is like if condition, then else condition. Then we are simply write here system dot out dot println, and here we are print the count. So here what happen? Like there are three three values present of the variable number 2. So I am writing here key is 2 and the value of 2 is 3 here. So what is the value of k here? K is 1 here. Okay. So if value is less than k, so value is 3, but k is 1. So value is not less than k. Here you can see here, guys, like the key is 2 and the value of 2 is 3 here. Okay. So the value is 3 here. 3 is less than k. So this condition is not executed. So if this condition is executed, then only machine number A is executed. Why? Machine A. And this is for the machine number B. So in this, energy is given in question. In question. And in this, energy is fixed. That is 1 here. Okay. So guys, if value is less than k, like value is 3, but k is 1. So if we are execute machine number 1, then we can like we add the value of 1 again and again, like value is 3. So this machine is executed 3 times. So that's why it can remove the 2 3 times, 1 2 and 3. So value is 3. So we are adding the value in our counts, like 3 energy is required here. We are adding 3 in this case if we are executing this thing. So this is not beneficial because this can be done only for energy consumption of 1 unit by the machine B, because you know very well in this the value of k is 1 and the value is 3 here. So else condition is executed. Like we can if this value is less than k, like value is 3 here, k is 1. So this is not executed. Machine 1 is not executed. So machine B is executed. So machine, we know very well, machine B consume the less energy. So that's why we are only we are adding only in this count is only 1. So we are adding only 1 in our count. So why we are adding 1 in our count? Because when we consume our like when we run our second machine, so its second machine take the 1 unit of energy and it can remove the 2 in one way. So it only add the 1 unit of energy. Okay. So that's the reason. In this case, guys, in the second test case, you can see here, there are 1%, 3% alone. If we are take the 3, the what is the value of 3 here? key is 3 and value is also 1. So 1 is less than this k. 1 and the k is 2 here. Value of 3 is 1 here. So value is less than k. Yes, value is less than k. So at that time, what we can write here? We can only add the value. So only adding the value means we are running our first machine. We can only perform the operation of machine number one, that can only one unit, and this is only one element present. It can be removed by the machine number one. So that's why these are the two operation for the machine one and machine two. If we have machine one, we are using the machine one, then we are adding the value. Why we are adding the value? Because if two have three values, so our machine one is running three times, so we can add in the count is three, and we run our loop for the second entry. If the second machine is executed, then we know very well we are only adding the k unit. K is the mention in this question, like it can be 2, 3, 4, 5, anything. Like the value is not less than k, and then else condition is executed and count is increasing by that k. Okay, so that is the all like easy solution of this question. Hope you are understand. I run this. So map dot contains key. Sorry for that. Here is we are right element. So you can see here 4422, that are our answer. So you can use this approach for solving this question. Hope you are understand that I explained to you. If you have any doubt regarding this question, then you can ask in the comment section also. If you like the video little bit, you can like the video, and if you like more than little bit, you can subscribe the channel. So thank you so much, guys.